Hi to you watching this video. So for this video, we're going to discuss about Module 11. So it is the Introduction to Engineering Surveys. So this module will explain the concepts of engineering surveys and identify the operation stages in locating a railroad or highways. Okay, so yeah, let's get it on. So what is engineering surveys? So it is common or it is otherwise called route surveying. So engineering surveys supplies the data necessary to determine alignment, grading, and earthwork quantities for the design and construction of various engineering projects such as roads, railroads, pipelines, and utilities. So every data or information that we need in constructing railroads, pipelines, and utilities will be given by the engineering surveys. Okay, so operation and stages in locating a railroad or highway. So we have the Reconnaissance survey, the preliminary survey, the location survey, and the construction survey. So what is a Reconnaissance survey? So the Reconnaissance survey is an extensive study of an entire area that might be used for for a road or airfield. Its supposed purpose is to eliminate those routes or sites which are impractical or unfeasible and to identify the more promising routes or sites. So for a reconnaissance survey, one of the purpose is uh, tanggalin na natin yung mga hindi pwedeng possible na gawing kalsada or railroads. And it gives us more information sa mga possible routes na pwede nating gawin as roads or railways. Okay. Next would be existing maps and aerial photographs may be of great help. Contour maps show the terrain, features, and relief of an area. Aerial photographs show up-to-date planimetric details. Okay, so it gives us the picture. So it gives us the picture the of what is the actual image in reality. Okay, so with the help, of course, of technology. So the Reconnaissance survey must include all possible routes and sites. I repeat, it must include all possible routes and sites. The Reconnaissance survey report should summarize all the collected information, including a description of each route or site, a conclusion on the economy of its use, and where possible, appropriate maps and aerial photographs. Okay, so that is the scope of a reconnaissance survey. Now, in the design and military characteristics should be considered during the reconnaissance survey. So keep in mind that future operations may require an expanded road net. A study of the route plans and specifications is necessary. If these are unavailable, use the following as guidelines. So in the design, it locates portions of new road along or over existing roads, railroads, or trails whenever possible. It also locates the road on high bearing strength soil. So when we say high bearing strength soil, ito yung mga kayang magbuhat ng mabibigat na na soil. Na kayang mga soil na kayang magbuhat ng mabibigat na weight. Okay? That is stable and easily drained. Avoid swamps, marshes, and organic soil. And next, we have to consider that along road ridges and streamlines, keeping drainage structure to a minimum and keep grade well above the high water line when flowing a stream. Okay. Next, select a route as near to source of material as practical and locate the road along contour lines to avoid unnecessary earthwork. So it is important for us to locate our route near the source of material so as the hauling or yung pag-transport ng material would be less costly. Okay? And of course, it would be more practical. And that is to avoid and contour lines that is to avoid unnecessary earthwork. Take note every work in the construction is equivalent to money. So as much as possible, if we can reduce the work, then we reduce our costing. Okay, so locate the road on the sunny side of hills and canyons, and on that side of the canyon wall where the inclination of the strata tends to support the road rather than cause the road to slide into the canyon. Okay, so the strata is very important in locating your railroads. Next, locate roads in forward combat zones so that they are concealed and protected from enemy fire. So this may at times conflict with engineering considerations. So of course these are military tactics, no, that needs to be in consideration, of course, for national security purposes. But most, if not most, but there will be times that it will be quite in conflict with engineering consideration because of strategic reasons. Next, select locations which conserve engineer assets. Avoid rock work and excessive clearing. Take note, rock work is quite costly, time consuming compared to earthworks because rocks are heavier to transport, and it is quite difficult um to yeah, it is also difficult to transfer, and what broke or break into pieces. Okay, avoid sharp curves and locations which involve bridging. Okay, next would be the roadway criteria. To ensure satisfactory results, study the build. Okay, alamin nyo yung build ng kalsada. If these are not available, use the engineering specifications of the road to be information provided in the following table. So here are the road specifications. So when we say width, ito yung lapad ng kalsada. Okay, so this is what we call the width of the road. Okay, so if it is a one-way road, okay, or ito, one-way road, ibig sabihin, isa lang yung direction. The direction of the flow of traffic is one way. It's either going there or it's going here. Okay? That is a one-way road. And for a one-way road, it has to have a 11.5 feet or 3.5 meter minimum width. Okay, so the minimum width of a one-way road is 3.5 meter, or it is 11.5 meter. Okay, if it is a two-way road, it should be 23 feet or 7 meters minimum. Okay, so this is a two-way road, isang direction pa ganon, isang direction pa ganito. So this is 3.5 meters and this is also 3.5 meter. Therefore, the minimum width for a two-way road is 7 meters. Okay, so shoulders each side 4 feet or 1.5 meters minimum. Clearing should be 6 feet or 2 meters each side of the roadway. Okay, so when we say clearing, nandito yon dapat. Okay, but yeah, normally kasi when it is a rural, it is not it is a rural, it is not being followed because it is not that populous. But for an urban, it is quite strict. Okay, next would be the grades. So absolute maximum determined by the lowest maximum gradability of vehicles using the road. Okay, so when we say grade, it is the vertical, yung slope, pagtaas at pagbaba ng kalsada. Okay, that is what we call the grade. It is with respect to vertical. Okay, so pagtaas at pagbaba ng kalsada. Wait, let's try to find okay, so this example here, if we're going to zoom, yeah, so that is grade. So pagbaba and pagtaas ng kalsada. That is what we are pertaining when we say grade. Then normal maximum, it is 10%. So desired maximum less than 6%. On sharp curves less than 4%. So for and the normal maximum grade is 10%. May it be positive if it is going up, negative it is going down. So the desired maximum, but the desired maximum is should be less than 6% on sharp curves. Less than 6%. Now on sharp curves, it should be less than 4%. Take note this specifications were designed with respect to safety. Okay? Now, when we say horizontal curve, ito yung pag-zigzag. So, this is the shifting of direction, north, south, east, west. Yan yung pag-zigzag. Okay? So, for example, here, it is this direction, then it is shifting towards that direction. So, that is horizontal curve. Okay, now with respect to elevation, that is vertical curve, okay, or that is with respect to the grade. Now, the desired minimum radius, which is 150 feet or 46 meters. Now, we will try to understand later on yung desired radius. Now, when we say, when we say road, okay, if there is a curvature, we try to imagine na meron tayong malaking circle. Okay, so we have a big circle here, and the curve in your road is a portion of that circle. And pag may circle tayo, we have a radius. Okay, radius from the center to the center of the circle to the center of the road. Okay, so yun yung sinasabi nating radius. Okay, so we will try to imagine that more when we will be having our example. Okay, so the absolute minimum radius is 80 feet or 25 meters minimum, absolute minimum, but the desired minimum should be around 46 meters. Okay, now for vertical curves, the minimum length on hill summits is 125 feet or 40 feet or 40 meters as per 4% algebraic difference in the grade. So, yung pagtaas at saka yung pagbaba, of course, may curve din yan. Yung pagtaas and pagbaba ng curve natin, imagine, take note, yung sa curve, mag-imagine ka ulit ng circle natin. Then, yung nakadugtong sa kalsada, ikat natin yung portion na yun, that would be an arc of a circle, and it has a radius. Okay? So, the minimum length of hollows should be in 100 feet or 30 meters per 4% algebraic difference in grades. Okay, next would be the sight distance. When we say sight distance, it is, ito yung natatanaw mo habang, for example, you are here, you are approaching this direction. Now, kung ano yung natatanaw mo sa kalsada na clear vision, that is what we call the sight. That is what we call sight. Now, for that is your visible sight. Now, yung distance na clear na nakikita mo whether you're on the passenger or the driver's side is what we call the sight distance. Okay, and we compute that for the sake of safety. Okay, so absolute non-passing minimum should be 200 feet or 60 meters. Absolute passing minimum is 110 meters. Now for the slopes, shoulders should be 3/4 inch per foot or 6%. Now for the crown, it should be 6%. Crown, if it is a paid one, it should be 4%. Cut and fill, ibig sabihin of if bundok yan, then gagawin natin kalsada yung gilid. We are going to build a road. Cut, ibig sabihin magbabawas tayo ng soil. We're going to reduce soil. Fill, ibig sabihin we're going to fill in soil. Cut and fill. Okay? So variable, but normally about 1.5 inch to 1 inch. Okay? Now for the drainage, take advantage of natural drainage. Like what I have said in our contour, due to gravity, everything falls down, and the lowest point would be the best drainage. So if you are quite familiar, if you are, for example, let's say you're having an ocular inspection or a contour survey, or you're trying to have a feasibility study, and you are planning to construct a structure sa mga riverside, I strongly suggest that you reconsider that, unless the elevation for the location that you're going to build is quite high, because that is a natural drainage. So pag umulan, bumagyo, all the waters that are coming from upstream will go there. And of course, it is expected na tataas yung level of water, because that is a natural drainage. Okay, so sabi dito, take advantage of natural drainage. So if we're going to alterate the natural drainage, it would be costly. Okay, because that is already the natural drainage. Why change? Okay, but if there will be project or for construction purposes, kailangan ibahin, then so be it. But make sure that it is the design would be safe. Okay. Next, locate above high water line near streams or creeks. Okay. So, importante malaman yan, natin yan, so as to avoid damage in the structure in the future, if in case magkaroon ng flooding. Okay. So, grade at least 5 feet or 1.6 meter above groundwater table. Next, for traffic, overhead clearance it should be 14 feet or 4.3 meter minimum. When we say overhead clearance, if this is, for example, this is your road, yung vertical clearance, ibig sabihin, dapat makakadaan pa rin yung sasakyan na hindi lalagpas sa 4.3 meter. Now, if lalagpas na yan sa 4.3 meter, yung dadaan na sasakyan or sabihin natin na truck, yung vertical clearance natin is 4.3, hindi na siya makakadaan. Okay, so let's try to search vertical clearance. So, vertical clearance, it is the vertical distance. Yan. Like for example, this. So yeah, so it is from the road up to the lower part of this bridge. Okay, so that is the vertical clearance. Ibig sabihin, pwedeng makalusot dyan hanggat hindi nag-exceed dun sa vertical clearance natin, until it is below the vertical clearance. So this is what you call the vertical clearance. Okay. So traffic volume, 2,000 vehicles per lane per day. When we say traffic volume, it is the amount of cars or vehicles that are passing through a certain lane per day. Okay, but it is being computed per hour, vehicle per hour per lane. Okay. Next, load capacity, it should sustain 18,000 pound equivalent actual load. So yung mga kalsada natin, they are designed, of course, to carry a certain load. And because yung mga dumadaan dyan, like for example, if it is a 10-wheeler truck and it is carrying its maximum capacity, it is carrying its maximum load, then it should have, or it should be able to sustain an 18-pound actual load. Actual load, ibig sabihin, it is a downward force since the weight of the vehicle is downward, and it is in compression. And turns out, single lane, minimum every 1/4 mile or 0.4 kilometer recommended. Now, for Reconnaissance survey, the collection of data would be, upon completion, the Reconnaissance survey should support the routes surveyed and provide a basis of study showing the advantages and disadvantages of all routes reconnoitered or considered or surveyed. Typical data collected in a reconnaissance survey are, so you have here the sketches of all routes, reports of feasible routes, data on clearing and grabbing. Ibig sabihin yung pag-clear ng mga if there are what you call this, there are grass or there are debris, so you clear them and you grab them. Next, the number of streams crossing involving bridge spans exceeding 20 feet or 6 meters. Approximate number of culverts and spans less than 20 feet or 6 meters. Description and sizes of marsh areas and other natural obstacles. Unusual grade and alignment problems encountered. Anticipated effects of landslides, melting snow, and rainfall. Soil conditions and stream and substrata conditions and proposed bridges. So all in all, everything that needs to be considered in the engineering of the road should be included here. So that the best decision should be made in terms of economy and in terms of engineering. Okay? So lahat ng mga pwedeng dapat i-consider when constructing a road or railroad should be here para yung decision maging maganda in terms of pagpili kung saan ilalagay yung kalsada. Okay? So, yeah. And use of maps. The procurement of maps is a very important phase of the Reconnaissance. The surveyor should locate and use all existing maps, including up-to-date aerial photographs of the area of reconnoitered. So large-scale topographic maps are desirable because they depict the terrain in the greatest detail. The map, which overlays, serve as worksheets for plotting trial alignments and approximate grades and distances. So the surveyor begins a map study by marking the limiting boundaries and specified terminals directly on the map. So this is the procedure. So between boundaries and specified terminals, the surveyor observes the existing routes, ridge lines, water courses, mountain gaps, and similar control features. So the surveyor must look for the terrain which will also allow moderate grades, simplicity of alignment, and balance between the cut and fill. So what we are trying to say here is that with the help of map, the surveyor will try to check all the natural features or the man-made features so that we can try to avoid them or we can try to maximize them in its full capacity with respect to the design or for the purpose of our engineering construction. So we also need to consider the grades because take note, we are hindi ang ni-design natin dito more or less would not just be a small span of length. This is a kilometers or miles of distances. So what we are trying to do here is to have a safe road, and at the same time it is in collaboration with economy. Okay, because of course everything involves money. So after closer inspection, the routes that appear to fit the situation are classified. As further study shows disadvantages of each route, the surveyor lowers the classification. So the routes to be further reconnoitered in the field are marked using pencils in different colors to denote priority or preference. So dito tinatanggalan ng surveyor yung mga hindi ganun ka feasible na gawing kalsada or daanan ng kalsada, and yung mga mas feasible then yun yung magpo-proceed sa next level of consideration. Okay, so taking advantage of the existing terrain condition to keep excavation to minimum, the surveyor determines grades, estimates the amount of clearing to be done on each route and marks stream crossing and marsh areas for possible fords, bridges, and or culverts crossing. Okay, next would be a preliminary survey. So for the scope, the preliminary survey is a detailed study of a route tentatively selected on the basis of Reconnaissance survey information and recommendation. So dito magkakaroon na tayo ng detailed study ng mga possible na route that were tentatively selected during the Reconnaissance survey. Okay, so it runs a traverse along the proposed route, establish levels, records topography, and plot results. It also determines the final location from this plot or preliminary map. The size and scope of the project will determine the nature and depth of the preliminary survey for most military construction. Okay, so here we are already going to employ personnel. Okay, so a survey effort establishes a traverse with control and reference points, or it may expand to include leveling and topographic detail. So normally, obtaining the traverse, leveling, and topographic data are separate survey efforts. So, but this does not preclude combining them to make the most efficient use of personnel and equipment. Okay, next is a traverse party. So, what is a traverse party? So, the role of a traverse party is to establish the traverse line along the proposed route by setting and referencing control points. Okay, so sila yung nag-establish ng traverse line sa proposed routes. So measuring distances, numbering stations, and establishing points of intersection. So the party also makes the necessary ties to an existing control if available or required. When no control is available, the party may assign a starting value for control purposes, which can later be tied to a control point established by geodetic surveyors. Okay. Next would be a level party. So, as a level party, they establishes benchmarks and determine the elevation of selected points along the route to provide control for future surveys. So for traverse party, it is the horizontal. For level party, it is the vertical. Okay, so we establish vertical distances or elevations so that if you're going to have this in use in the future or reference in the future, it will be available. So, such as preparation of topographic map, profile, and cross-section leveling. So the level party takes rod readings and records elevations to the nearest 0.01 foot or 0.001 meter. So it must be precise. So it sets the benchmark into a place well out of the area of construction and marks them in such a way that they will remain in place throughout the whole project. If there is no established vertical control point available, establish an arbitrary elevation that may be tied to a vertical control point later. An assigned value for an arbitrary elevation must be large enough to avoid negative elevation at any points on the project. Next would be a topographic party. So the topographic party, they are the ones uh, task for that secures enough relief and planimetric detail with the prescribed area. So they locate any obstacles and allow preparation of rough profiles and cross sections. They also do the computation for the data that would determine the final location. So the instruments and personnel combinations used vary with survey purpose, terrain, and available time. Okay. Next would be a transit data transit uh, stagia party. So transit stagia party. So the transit stagia party is effective in open country where comparatively long, clear sites can be obtained without excessive brush cutting. And lastly, we have the plane table party. So the plane table party use where the terrain is irregular. So for short route surveys, the procedure is much more the same as the transit data method, except that the field work and the drawing of the map are carried on simultaneously. Okay, so we will be using here the table. Okay, so kung maalala niyo yung previous module natin, we have there the plane surveying. Okay, so we will be using that here. Next would be the location survey. So for the location survey, the scope, it is prior to the final location survey, office studies consisting of the preparation of a map from preliminary survey data, projection of a tentative alignment profile, and preliminary estimates of quantities and costs are made and used as guidance for final location phase. So like what I've said, money is the one of the most important factor to be considered in any project. Okay? So like katulad dito, it is one of the factor that will be considered in the final location of our roads. Okay, so when we say uh, estimates of quantities, these are the materials, the equipments, the apparatuses that needs to be that will be used in the project and their costings. So estimate the quantity and costs kung magkano. Next would be running the center line. The center line may vary from the paper location due to objects or conditions that were not previously considered. So the final center line determines all the construction lines. The surveyor marks the stations, runs the levels, and sets the grades. The center line starts at station 00. Excuse me. The surveyor numbers the stations consecutively and set them at the full 100 foot or 30-meter station. 100 foot for the English system, meter in for the metric system. So station, ibig sabihin nasa zero ka or nasa beginning ka. As we progress, nadadagdagan yung value natin dito. So this one is in feet. So ang pinakamataas na value dito is 99 feet. Pag naging 109, mapupunta dito yung 1, matitira dito yung 9. So that is 109. Okay? So the surveyor also sets stakes at important points along the center line. This may be culvert locations, road intersection, beginnings and ends of culvert curves, or breaks in the grade. So when measurements are made in feet, these stations are numbered from the last full station. Okay, so they are called plus stations. A station numbered 4 plus 44.75 would be 44 feet away from station 4 or 400 feet. Okay, and if you're going to read this is 444.75 feet from the beginning of the project. So when using the metric system, the total distance from the beginning of the project would be 135 meters, and that would be numbered 135.56. Now the reference stakes. The center line starts at station 00. So the surveyor numbers the station consecutively and set them at full 100 foot or 30-meter station. The surveyor also sets stakes at important points along the center line. This may be culvert location. Naulit. Okay. Next would be profile and cross section. So after the center line of the road, including the horizontal curves, has been staked, the next step in the road layout is the determination of elevations along the center line and laterally across the road. So just to give you an imagination what is a center line, pag nagkaroon kasi tayo ng survey, what the surveyor or the engineer, geodetic engineer is considering is not the sides of the road. Okay, it is the center. Okay, so it's not moving. So yeah. So ang kino-consider sa survey or ang ginagamit sa survey is the center line. Saka mag-go wide to the left and to the right. Okay? So when we say center line, we are pertaining to the center of the road. So what if it is a 4 lane na isa pong lane pa dito? May so bale 1, 2, 3, 4. Again, it is still the center line that we are surveying in the field. Okay? So the surveyor performs these operations known as profile leveling and cross-section leveling as separate operations but at the same time as the elevation of points along the center line or fixed line. So dito kinukuha na natin yung vertical difference. So the interval usually coincides with the station interval, but shorter intervals may be necessary due to abrupt change in terrain. So the plotting of the center line elevations is known as the profile. So pag pinaplot na natin yung elevation netong center line, then that is what we call profiling. Okay? So from this profile, the design engineer determines the grade of the road. So grade, ibig sabihin, it is the pagtaas or pagbaba ng road. Okay, vertical. So, where are we? Ayan. The cross-section elevations make it possible to plot views of the road across the road at right angles. These plotted cross-sections determine the volume of earthwork to be moved. The surveyor establishes the cross-section lines at regular stations, at any plus station, and at intermediate breaks in the ground, and lays out the short cross lines by eye and long cross lines at 90-degree angle to the center line with an instrument. So all elevations at abrupt changes or breaks in the ground are measured with a rod and level. With a rod and level rather. And distances from the center line are measured with tape. So I repeat, the grounds are measured with rod and level. So that is for the elevation. Now for the distance from the center line, it is measured with a tape. In rough country, the surveyor uses the hand level to obtain cross sections of the center line. Elevations have been determined using the engineer level. Okay. Construction survey. So the construction layout is an instrument survey. So it provides the alignment grades, and locations which guide the construction operations. So of course, when we do construct, hindi naman agad-agad napupunta ka na doon, magko-construct ka. Okay? So we have points that needs to be followed. So, nandun yung mga points kung saan yung huhukayin, doon lalagay yung ganito, doon i-construct yung ganito. So, that is construction survey. So, we have guidelines to follow. And that is being laid out by the geodetic or the surveyor. Geodetic engineer or the surveyor. The construction operations include clearing, grabbing, stripping, drainage, rough grading, finishing grading, and surfacing. So, this is, kumbaga, we are already conditioning the, we're already conditioning yung location kung saan natin gagawin yung kalsada. Okay? Take note, all of these are part of the pre-construction. We have the pre-construction phase, construction phase, and the post-construction. Or ibig sabihin, yung pre-construction, nandiyan yung planning, designing, surveying. Surveying, planning, designing. Then, for the construction phase, doon na ginagawa yung structure. Then, for the post-construction, dyan na yung na-turnover na and ginagagamit na siya and nagkakaroon na tayo ng maintenance. Okay? The command must keep uh, the command must keep the surveyors sufficient ahead of the construction activity in both the time and distance to guarantee uninterrupted progress of the construction effort. Note the following suggestion or suggested distances. So keep center line established 1,500 feet or 450 meter ahead of clearing grabbing. Okay? So it must be ahead 450 meters from a clearing and grabbing. So keep rough grade established and slope stakes set 1,000 feet or 300 meters ahead of stripping and rough grading. So set stakes to exact grade 500 feet or 150 meters ahead of finishing grading and surfacing. Next is alignment. The surveyor must place the alignment markers ahead of the crews engaged in the various phases of construction. Of course, the surveyor must be ahead of his game because he is the one who is setting the guides, or the guide rather, or he is the guide for the whole construction because yung mga i-establish yung points, doon natin i-layout yung ating kalsada or railroad. Okay? So, major structures such as tunnels and bridges involve a site survey. The general demarcation of the site boundaries is carried on with establishment of the route alignment. The layout of the site proper is a separate setting or survey. So setting grade stakes. So grade stakes indicate the exact grade elevation. So this is the exact grade elevation, like like the other term, it is profiling. So the surveyor consults the construction plans to determine the exact elevation of the subgrade and distances of the center line to the edge of the shoulder. Next would be setting slope stakes. Slope stakes indicate the intersection of cut or fills. So, saan magmi-meet yung pagbungkal mo and yung fill or pagtabon mo ng lupa. Okay? With the natural ground line. So, they indicate the earthwork limits on each side of the center line. Next is a culvert location. Now, ano ba yung sinasabi nating culvert? Yung culvert, yan yung dinadaanan or yan yung drainage. Okay? Culvert. Yan yung, ito, para ma-imagine nyo. Yan. So, this one is a culvert. Okay? That is a culvert. That is a culvert. Culvert, 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 culvert. Okay? So, that is the drainage. Okay? Yeah. Ito yun. When we say culvert, hindi siya yung, it is a part of the drainage, pero siya yung structure. Okay? So, ito. This is a culvert, culvert, culvert. So, yung pipelines na nakikita nyo, that is a culvert sa mga ginagawang kalsada dito sa Philippines. Okay? Concrete pipe. Concrete, though we do not call that pipe, but it is a pipe, yeah. So, that yung circle and concrete hollow na yan, that is a culvert. Okay? Next is the drainage. To establish the layout of sites such as culvert, the surveyor locates the intersection of the roadway, center line, and direction. So, dapat na-establish na yan beforehand because it would be not one time, it would be a simultaneous activity. So, Yeah. So dapat na minsan ginagawa na yung drainage, tapos on top of that nandun yung kalsada, may mga ganong kalsada. So meron din naman yung mga kalsada niya, tapos sa gilid is yung drainage natin. So most of the time they come hand in hand in terms of construction phase, hand in hand, or side by side rather. So that is the correct term. Okay. So, to establish the layout of such a culvert, the surveyor locates the intersection of the roadway center line and a line defining the direction of the culvert. Generally, culverts are designed to conform with natural drainage lines. Okay, so the surveyor places stakes to mark the inlet and outlet points, and any cut or fill, if needed, is marked on them. The construction plans for the site are carefully followed, and the alignment of the drainage stakes, the grade stakes, are set on the center lines beyond the work area. Thus, any line stakes or stake which is disturbed or destroyed during the work can be replaced easily. Okay, so that is the introduction of curves.